Hey guys, so I'm going to be gone for the next little bit of time, so I'm going to just put up some videos about the notes from the days I'm going to be missing. So I'm going to talk about lesson 2-3, intercepts of graphs. Intercepts of graphs are points where the graphs intersect an axis. So the x-intercept is the x-coordinate of a point where a graph crosses the x-axis. The x-axis is that bold horizontal line right there. Sorry, drawing on my computer, so it might not be the best, and I apologize for that. Okay, but it's that line right there. Okay, it's when the graph crosses that line. So you can have 0, 1, 2, 3, you can have up to infinity. X-intercepts. The y-intercept is the y-coordinate of a point where a graph crosses the y-axis. And the y-axis is the bold vertical line. Alright? So, now when we talk about a function is positive when its graph lies above the x-axis. So that's any point in which it's above that line. Any point above that line. And how we write these is always going to be x. It's always going to be an x value of some sort. And then it's going to be less than, or x is going to be greater than, your x-intercept. Your x-int. X-int. So we'll go through a few examples in a second. So again, positive is when it's above that blue line, that x-axis, that x-intercept line. And it's negative when it's below. All right, you can think of that x-intercept almost like the ground. You can think of this line right here as the ground. Anytime you're above it, you're positive, you're above ground. Anytime you're below it, you're below ground or negative. All right, just a way you can think of it. Example 1. Intercepts of the graph of a linear function. Use the graph to estimate the x-intercept and y-intercepts of the function. Describe where the function is positive and negative. So we'll zoom in. All right. So we see that we crossed the x-axis right here. And we always want to start counting right there at the origin where the x and y axes meet. So this is going to be 3, 0. 3, 0. We want 1, 2, 3 to the right. Right is positive. And just a reminder, x-intercepts. The y value will always be 0 on an x-intercept. So whatever intercept they're asking for, the other variable will be 0. So for a y-intercept, x will be 0. And we're going to go up 1, 2, 3, 4, 5, 6. So it's 0, 6. Function, so I'm going to erase this now, just so we have some, so we know for positive and negative. So it's going to be positive. The function is positive when it's above that line right there. Okay? And the point at which we cross is 3. So at 3, it's a neutral point. It's not positive or negative. All right? So that's why we always have to use that as our gauge. Now, when is it going to be above that line? Well, anytime x is smaller than 3. So how you can do this, the way you can do this is pick a number. Any number other than 3. So in this case, let's try 1. So on this x value of 1, we had to go above the line. And 1 is less than 3. Therefore, it has to be below. It will be below. X will be less than 3. And it will be above the graph. Okay? So when x is larger than or greater than 3, it'll be below the x-axis. It'll be below the x-axis. Therefore, it'll be negative. All right. Go down, try to check. Pause the video. I'll give you a few seconds. All right, welcome back. Hopefully you paused it. Hopefully you got an answer. So we can see this is the x-intercept. This is the y-intercept. So that's 1, 2. But since we went left, it's going to be negative. So we can eliminate B and D. All right. A and C both have -6 as our y-intercept, which is perfect. So now we need to check. So when x is less than negative 2, so all these values over here, all these values, it's going to be positive. So that symbol, the inequality symbol, always wants to eat the bigger thing. It always wants to eat the bigger number, okay? So when negative 2 is bigger than x, it's going to be positive. Okay. Example 2. So now we're no longer looking at a linear function, all right? So x-intercepts, now we're going to have 2 x-intercepts, where before we only had 1. So now we have 2. So we have x-intercepts at negative 4 and at positive 3. And the y-intercepts all the way down here at 12. Now it's going to be positive in 2 locations. It's going to be positive in 2 locations, from here to here and there to there. So that's when it's positive. So when x is less than negative 4, and when x is greater than 3, you can also write it like this. X, sorry. As long as it's eating x on the right side, and on the left side, it's got to be eating the negative 4. It's negative between negative 4 and 3. So the inequality you'd write would be negative 4, x, and 3. So that would be for this one. All right. Again, try to check. Pause it. I'll give you a few seconds. Pause it. I'll give you a few seconds. All right, welcome back. Determine whether each ordered pair represents x-intercept, y-intercept, or neither. So 1 comma 0, that's 1 to the right, none up, and that does. So that is a, sorry, I was going to put yes. This is an x-int, an x-intercept. 0 comma 1 doesn't move left to right, goes up 1. That doesn't cross our blue graph, so it's neither. That's neither. Now we need to look for when it's positive and negative. So it's negative from negative infinity. So when x is less than 1, it's going to be negative. And when x is greater than 4, so every point after 4 this way, it's below that line, so therefore it's also when x is greater than 4. It's going to be negative. And then between 1 and 4, so during all of this right here, it's positive. It's above that line. All right? Here we go. Example 3. Now we're actually getting into a real-world problem. Okay, so the graph shows the height of a ball for each second x that it is airborne. Use the graph to estimate the x and y intercepts of the function, where the function is positive and negative, and interpret the meanings in the context of the situation. So the x-intercept is 9. That's where it crosses down there. The x-intercept is 9. That means that the ball will hit the ground after 9 seconds. That makes sense. If you hit the ball, it goes up and then it goes down. And you can think about that horizontal line like the ground, because it is like the ground, because height is y. So when it's 0, when there's no height, you're on the ground. The y-intercept is going to be 4. It's right up here. Okay, this means that at time 0, okay, time was 0. So time was 0. We went up to 4. The ball was at a height of 4. That means the batter, in this case, hit the ball, and he was 4 feet above the ground. All right. So function is positive when x is between 0 and 9. Okay, which means the ball was in the air for 9 seconds. Okay, so the whole time we're above the ground. We're never below the ground. That's why no portion of this graph shows the function is negative, because we're above the ground. The ball never went below the ground, therefore we're always above it, so it's always going to be positive. All right? Try the check, try the check, try the check. All right, welcome back. The x-intercept is 12, 0, and the y-intercept is 0, 20. So which statement describes the meaning of the x and y-intercept in the context of the situation? Select all that apply. Gotta scroll down a little bit, sorry. Oh, excuse me, sorry. Here we go. All right, so there were 20 people at the gym when it opened. I would say that's true. All right, because right here, that's what the y-intercept's saying. The number of people is the y. Time is the x. So at 0, when the gym opened, there were about 20 people there. So I'd say A. B, the gym closed after 20 hours. Well, that's not true. It closed after 12 hours. It can't be B, but it can be C because if you look here, no one was there after 12 hours. That's because, well, it closed. There are 12 people at the gym when it opened. No, that's the time it closed, when there were no people left. There was no one at the gym when it opened. That's not true. It didn't start at the origin. Therefore, that is not true as well. So A and C. A and C. All right, we need to find the intercepts from a table. From a table, let's find the intercepts. How we can do this is wherever you see zeros, anytime you see zeros on a table, that's going to be your x or y intercept. How you can tell, again, is whichever one is 0. So if x is 0, that's your y intercept. If y is 0, that's your x intercept. All right, so whatever variable is 0, it's the opposite intercept. So if x is 0, it's the y-intercept. If y is 0, it's the x-intercept. All right. Sorry. So I'm going to scroll down a little bit. Okay. All right, so the x-intercept is where y equals 0. So the x-intercept is 40. The x-intercept is where, or the y-intercept is where x is 0, so the y-intercept is 150. The x-intercept means that after buying lunch for 40 days, Violet will have $0 left in her lunch account. So what this was asking you, hopefully you read it, Violet starts the semester with $150 in her student lunch account. So her parents put $150 in her account, and every day she spends $3.75 on lunch. If her parents or herself were not to ever put money back into the account, how many days could she buy lunch for before it ran out? That's what our x-intercept is going to tell us. When that money runs out, she has eaten for how many days? And in this case, 40. All right? So it will take Violet 40 days to use all of the money in the account. The y-intercept is always going to be your starting amount. The starting amount, the beginning, the initial, those are all buzzwords for the y-intercept. So y-intercept means that Violet's lunch account has $150 after buying lunch for 0 days because it's the starting amount, the beginning amount. So the beginning balance was 150. So we're going to talk about this much more for the remainder of the year, but y-intercept is the beginning amount, the starting amount, the initial fee. All right? Okay. All right, try the check. Try the check. So you can pause the video and try it out yourself. All right, welcome back. Here we go. So we find our two intercepts. The y-intercept is when x is 0. So x is 0, and we get 90. It didn't really fit inside that for me, so I just wrote 90 to the side. But it's supposed to go inside that parentheses right there. Find the x-intercepts and interpret the meaning. So we already found our y-intercept of 0, 90. So now we need to see that our x-intercept is 10, 0. So B and D are out. You can't see D right now, but it's not D. All right. So x-intercept tells us after this amount of trips, you'll have no money left. So after 10 trips to the movies, there will be no money left on the gift card. That's what it's stating. Okay. Because Ashley received the gift card with $90 on it, So the y-intercept will be 90 in this case. That's the initial or beginning or starting amount on the skiff card. And the x-intercept's that the final amount that she would have, or how many times she's used it before there is no money left on her account. All right, solving equations by graphing. This is big. All right. Highlighter. Here we go. So the solution or root of an equation is a value that makes the equation true. A 0 is an x-intercept. So solution, root, 0, x-intercept, all the same thing. It's all a different word for the exact same thing. So you can see it any of those 4 ways, it'll mean the exact same thing. Okay? So, for example, the root of 3x equals 6 is 2. Basically, we're solving for our x values when y is 0. So we want to solve for x when y is 0. Because on an x-intercept, y is 0. The value of y is 0. So that's what we're going to be doing. Okay. So if we look here, solve negative 2x plus 7 equals 1. The book does it a little different way. I'm not the biggest fan of it. So I'm going to do it over on the side, and then we'll do it how the book wants to. So you get negative 2x plus 7 equals 1. All right. So if you subtract 7, you get negative 2x equals negative 6. Divide by negative 2, divide by negative 2. X will equal 3. Okay. So we see x equals 3. What the book wants us to do basically is get everything on one side. Everything on one side. We're not used to doing that. We typically want to get the variable on one side. But right now, the book wants us to get everything on one side so that we're left with 0. Okay. So now we get negative 2x plus 6 equals 0. So then we need to graph the left side of the equation. And once you graph it, we'll talk way more about graphing later. In Unit 3, we're going to be talking about graphing a whole lot. But to graph this, you go up 6. That the number without the variable is your y-intercept, so 6. And then the slope is down 2 to the right one, down 2 to the right one. So 1, 2, 1, 1, 2, 1, 1, 2, 1. So it's 3. So x equals 3 is still the right answer, just like we solved it down here. Or you could just looked at the graph and seen that it was 3. So the solution of the equation is 3. I know that's a little tricky and the book kind of makes it a little funky, but basically just solve for x, and whatever that solution is, that is your x-intercept. And remember, on an x-intercept, y is 0, so you can set the equation equal to 0. All right, for this one, we can look at we want to get everything on the same side, so they want us to add 3, so it's equal to 0. So you get x squared minus 4x plus 3 equals 0. When you graph that, we're going to talk about this, how to graph these in the second semester, so after Christmas break, so we're not going to talk about that quite yet. But just looking at the graph, you can see that there's 2 x-intercepts. One's at 1 and one's at 3. So the solution of the equation this has 2 solutions, which are 1 and 3. Okay? Now, how do we solve for a horizontal line? So when we solve this, we want to get everything on one side. So we add 5. 3 plus 5 is 8, so plus 8. And then we want to subtract 4x because we want to get everything on one side. 4x minus 4x is 0 on both sides. So it's 0 plus 8 equals 0 because 4x minus 4x, well, is 0. So we get 8 equals 0, or y equals 8. Because we're trying to set y equal to 0. Because on an x-intercept, y is 0. All right? So I'm going to scroll up a little bit. So f of x equals 8 or y equals 8, same thing. Remember, y and f of x are interchangeable with each other. Just a fancy way of saying y, f of x is. The graph does not intersect the x-axis. This means that there is No. 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 X-intercept, and therefore there is no solution. So this blue line up here never crosses this bold line down here. They're parallel, so that means they will never cross, therefore we have no solution in this case. There's no solution. No root, no x-intercept. Okay. And no zero. That's the other one, sorry. I was thinking about it. Alright, try the checks. Try the checks. Try to check. So we want to get everything on the same side. We want to try to get everything on the same side and then find the zeros. Get everything on the same side and then find the zeros. So this one would be y equals 1/2 x minus 2. This one would be y equals 5. So this has no zeros. This has 1 0 at 1, 2, 3, 4. At 4. Okay. Then if I scroll up a little bit, you're going to get right here 2 zeros at 3 and -2. And the function would be x squared minus x minus 6 equals y. Typically you put the y first, so I'll do that right now. Just didn't really have much room over here, but there we go. And again, the zeros are -2, 3. -2 and 3. Okay. Hopefully you got that. All right. Let's go down to the check down here. I like the check a little bit better than that one. It's a little wordy. So Blair's cell phone plan allows her to use 3 gigabytes of data, and she uses approximately 0.14 gigabytes of data each day. The function g equals 3 minus 0.14d represents the amount of data g in gigabytes she has left after d days. So part A, examine the graph of the function to estimate its 0 to the nearest day. So it looks something like 22. You might see 21, 22, that's okay. But let's solve it. Let's actually solve this, all right? So we're trying to solve when the amount of data is 0. And since g is the amount of data she has, we can set that equation equal to 0. Okay, so you set g equal to 0. So we subtract 3 from both sides, you get -3 equals -0.14d. And then divide by -0.14d. Or just by the -1.04. I'll grab my calculator real quick because so you get 3 divided by 0.01, or sorry, by 0.14. And that comes out to 21.4. So after 21.4 days, Blair has 0 gigabytes left. So that's why graphs sometimes aren't necessarily the best, because they're not as accurate as if you solve it. But you still get a rough estimate. We weren't that far off. We were 0.6 off, so it still gives you a good ballpark, but not 100% accurate all the time. Okay? Now at this point, look at Schoology for the homework. Look at Schoology for all the homework and classworks that you need. Okay, if you have any questions on this lesson, please feel free to message me on Schoology, email me, and I'll try to get back to you as soon as possible. Okay, thank you. Have a good one. Bye.